Yes.
And I hope you all are with your writing materials, your book and your pen. So the topic is chemical bonding, okay? And I believe it's a familiar topic for you at this level or stage that you are in now, okay? So in this lesson, we'll be talking about what chemical bonding is. We'll be talking about the types of bonds. We'll be talking about um, ionic bond as one of the types of bonds, covalent bonds. I believe, okay, covalent bond, dative bond, metallic bond, hydrogen bond, and we'll also talk about how to draw Lewis dots if we have time, how to write formula for ionic compounds, crisscross method. When you go and see, when you see something like Na2O, how do we know that there is supposed to be two here? How do we know what Na means, what O means? How do we know what to call this formula? Okay. Now and lastly, we would see one or two questions, one or two WAEC questions if we have the time. So firstly, what is chemical bonding? We are not going to say there's so many grammar or complex things, but this is a definition we can put in place. It is the force of attraction that holds atoms or ions together, okay, to form molecules or compounds. So that force that makes um one element and another element to come together is what chemical bonding have to do with. So not every when we talk about bonding, we are talking about elements, we are talking about electrons. And electrons are what make an atom. An atom is what an element identify as, okay, in most of these cases. So not every element in the periodic table would bond with another element in the periodic table. Okay, so we cannot be seeing sodium, for example, bonding with magnesium or sodium bonding with potassium because that is not how it works. There is how bonding work, and that is what we are going to be seeing in this lesson. Okay, so we have seen an introduction in the periodic table. We can liken bonding to a man and a woman, or someone that has something and you that do not have enough. When the two of you come together, you that don't know, you are benefiting from the other person. Let's say, for example, in your class, okay, let's say Melody, for example, um knows this topic, chemical bonding, and we have another person, let's say Winner. She doesn't know the topic chemical bonding, but she has good knowledge in, let's say, English. So when the two of you become friends, you that know chemistry will teach that one that knows English. So you are giving some good thing to that one. And that person that knows English is receiving from you, is getting from you. So that is how bonding happen. So sometimes we share knowledge, like if Melody is sharing English knowledge with Winner and Winner is sharing chemistry knowledge with Melody, while sometimes it's just one of them that is benefiting from the other. And so when this sharing of knowledge occur, everybody is satisfied, everybody is happy, everybody is stable. That is what bonding can be likened to. And we have different kinds of bonding. Remember we said there are force of attraction that we cause bonding. So for example, like in the example I stated, the force of attraction that will make Melody and Winner to be friends, for example, is the fact that um this one knows the subjects better than the other. Okay. Now we have different types of bonds, and the common ones that you would see in WAEC, for example, we have ionic bond, we have covalent, we have dative, which is a type of covalent bond. We also have metallic bond and hydrogen bond. Now let's begin from ionic bond. Please listen carefully. When we talk about ionic bond, ionic has to do with transfer of electron. Okay, when we say transfer of electron means one person has enough electron to give, and they tend to give it to the other person, or let's say one element in the periodic table has enough electron to give, and it gives to another element in the periodic table, making the both of them happy and stable. And then we cannot talk about stability, okay, without talking about electronic configuration of the periodic table. So in simple terms, we can say ionic bonding has to do with the transfer of electron. When we see this image here, this is a typical example of how ionic bonding operates. Okay, so for example, in the periodic table, let us say this is our periodic table. We know that this is group 1. We have hydrogen, helium, then we have lithium, beryllium, boron, carbon, and the rest of them. Then we have chlorine. Okay, let me just write the whole periodic table. But I believe every one of you here know the periodic table. So once I say group 1 elements, you are able to tell me what elements are found there. Am I correct? Winner. Hello, is there any science student here and who doesn't know about the periodic table? I can also see Suleiman. I don't know if he's a science student. I'm aware that Melody is just here to observe, so she's not science. And Winner is science, so I would want her to respond to me. And also Suleiman should tell us if he's also a science student.
Yes, ma.
All right. So I was asking, do you know the periodic table? Do you? I don't know if you are speaking, but I can't hear you. Suleiman. Okay, how about you, Winner?
Yes.
You know the periodic table, right? So aside from hydrogen and lithium that I've written on the screen, what other elements is in group 1 of the periodic table? You said? What other element is in group 1? Winner? Aside hydrogen and lithium, what other element is in group 1 of the periodic table? Is what? Okay. We also have sodium in group 1, and we also have potassium. And then in group 2, we have beryllium, boron in group 3, carbon. There's 1, 2, 3, 4, 5, 6, 7, and 8.
Please repeat the question again. Network.
Is someone saying something? I think your internet is probably bad because I can't hear, but I believe someone wants to say something. Okay. Carbon, nitrogen, oxygen, chlorine. Sorry, fluorine. Neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So these are the first 20 elements. We'll deal with only this first 20 first. Now, back to what ionic bonding is. We said it is transfer of electron. So who is transferring and who is receiving? When we are talking about transfer of electron, we are talking about electron moving from a donating element to an accepting element. Okay, from a donor to an acceptor. And in chemistry, donors are usually metals, the metals. Metals are the donors, and acceptors are usually the non-metals. And how do you know the metals and non-metals? Group 1 are metals. Group 1, group 2 also metals. Okay, so this is how you know the group that we are talking about. And then how do you know the acceptors? The non-metals. Okay, as you are going further away from group 1 and 2, you are approaching non-metallic um, qualities. Okay, so oxygen is a non-metal, and also that oxygen group, so including oxygen and sulfur, group 6. Also group 7 are non-metals. So these are the electron acceptors. Okay, so one other thing we can take notes of is that electron donors are positively charged and electron acceptors are negatively charged. So we can we can put it that in chemistry, it's just like the reverse of maths. You know that in maths, if someone is having a negative um sign, it means that the person has lost, right? But in chemistry, a negative sign would mean the person has accepted electron, and positive would mean the person has donated or lost electron. Okay, so it's like the reverse of what we would think in mathematics. Okay, now we have said right now that ionic bond has to do with transfer of electron. Now the transfer is going from donors, which are positively charged parts or positively charged ions or elements in the periodic table, to acceptors, which are negatively charged. So let us pick one metal and one non-metal that we bond by ionic bonding. So can anyone tell us of a metal and a non-metal that we can bond here?
That's what I do.
Hastin, are you telling us one? Hello? Yes? Okay, so a metal would be sodium. You can see it in group 1, and I said group 1 elements are all metals, right? So let us say sodium. And let us pick a non-metal like chlorine. So these two would bond by ionic bonding. Why? Because it has to do with transfer of electron from a metal to a non-metal. That is one key thing again that we can note about ionic bonding. Okay, here I wrote that it involves transfer of electron, and it also involved going from metal to non-metal. So you can see a question in your exam asking you which is formed by ionic bonding. A way you can easily know the answer is if the compound is made of a negative and a positively charged two ends, which negative and positively charged parts. Okay, and the positively charged will mean a metal. The negative charge would mean a non-metal, like chlorine. So if we want to do bonding between sodium and chlorine, how are they bonding? They are bonding because sodium in the periodic table, sodium is 11 and chlorine is 17. So if we want to write the electronic configuration, we have to have knowledge of electronic configuration before we're able to understand clearly what bonding is all about. So if we are writing the electronic configuration of this, we would say this is 281. I believe you all already know electronic configuration from your SS1. If you don't, someone should ask me questions now. Okay, and for chlorine, it's 2, 8, and 7. So what happens here is that, like I said in the last class, every member uh, of the periodic table wants to be stable. And to be stable would mean that your outermost shell, which is usually the last shell, the one that is carrying the last electron, like this one in this case now is 1, and this case now it's 7. Your outermost shell, the last number you can see, should be completely filled. And what is completely filled? What does completely filled mean? In this form of electronic configuration, it means having 8 electrons. So we can see that sodium is not completely filled because it is ending with 1, not 8. And chlorine is not completely filled because it's ending with 7, not 8. So stability would mean having your outermost shell having 8 electrons. That is complete filling, and that is stability. So since sodium and chlorine are both not stable because they are not completely filled, that is why they carry out bonding. That is why they will bond. But assuming they were stable, they would not bond with each other. They would not want to bond with any element because they are already stable. But elements bond with themselves in order to be stable. Now, every element in the periodic table are not stable except the element in group 8. Okay, this periodic table now, in all the periodic table, it is only this group 8, this last group of the periodic table, that are stable. So helium, neon, argon, and all the elements following them are the ones that are stable in the periodic table. So that is why they would hardly want to be bonding with any other element in the periodic table. So if we use the example we used earlier on, it's just like Melody knowing everything in chemistry. She knows all the topic. So she is completely filled with the knowledge of chemistry. And because of that, she wouldn't want to be making friends with anybody for the intention of let the person come and be teaching her chemistry, because she's already self-sufficient. She already has all the knowledge of chemistry, so she wouldn't be thinking of needing help from one of her classmates. So that is how group 8 elements are like. They have all that they need, and so they don't want to bond. They wouldn't have the need to bond with any other element so that they will get something that they lack. But you see, sodium and every other element that are not in group 8, they lack something. Some of them are lacking electrons to be completely filled, while others are having too much electrons that they need to give away. Now, metals are those ones that have too much electrons, like sodium, beryllium, magnesium, calcium. Okay, and non-metals are the ones that have insufficient, and so they need more. So since metals have more, okay, they would now want to give to non-metals that have less, okay, so that they will be filled. So now, how can this filling means it's what we call the octet structure, okay. Now for sodium, sodium is 2, 8, and 1, right? And I said for it to be stable and completely filled, the outermost shell has to be 8, not 1. So what can sodium do to achieve an outermost shell of 8, which means completeness? Okay, it can donate that 1. This 1 that it's having there is an extra, so it tends to donate it or give it off. Okay, and if it gives it off, sodium will now be written as sodium plus, because like I said earlier, plus means I have donated 1 electron. Okay, and so the electronic configuration for this will be 2, 8. I saw this in one of your past questions, by the way. Now so sodium has donated 1 out, so that it will have 8 as the outermost shell. Now how about chlorine? Chlorine is 17 and 2, 8, 7. Now which is easier to do? Is it for chlorine to donate 7 or to accept 1 so that it will be complete? 7 is a whole lot of number to be donating. It is easier for chlorine to just accept 1 and be complete. It's just like if you have a plot of land that you want to buy for, let's say, 8 million, and you have just 7 million naira. What are you going to do? Are you going to say, oh, let me just use the 7 million naira for something else? Okay, or let me forget about the land because I just lack 1 million naira more to be able to buy the land. That's not what anybody in their right senses would do. It is actually easier for you to maybe go and borrow or accept 1 million naira from somebody so that you'll be able to buy your 8 million naira land than for you to give off your 7 million naira to another person. Okay, so that is what is going to happen here. Chlorine is going to accept 1 electron than for it to donate or give off the 7 it already has. So if it's accepting 1, that means it's having 1 in addition to its 7. So chlorine is now, for chlorine to be stable, it will be accepting 1. And I told you accepting means acquiring a negative sign. So since it's accepting 1, it's just like chlorine minus 1, but you don't really need to write a 1. Okay, so we just chlorine minus. So chlorine minus would mean that chlorine that has this electronic configuration before has now accepted 1, and so it's now going to turn into 2, 8, 8. That is why sodium and chlorine would easily bond to be sodium chloride, because sodium has 1 to give off and chlorine needs 1. So both of them are helping each other to be stable. because if sodium needs to give off that one for it to be stable. So it also needs that is why chlorine is there to accept that one. It doesn't donate the one and leave it in the air. It has sodium has to give it to another ion, another element like chlorine, who is ready to accept one. Okay, so sodium will readily bond with chlorine because the both of them help each other to be stable, to achieve the octet rule. Now the both of them, when they donate and accept, they are now um they are now their outermost shell is now completely filled, which is 8 and 8. What has happened here is that sodium transferred one electron to chlorine, making chlorine 7 to turn to 8, and sodium no longer has this one. So that transfer of electron to make two elements to be completely filled is what ionic bonding is all about. And it's from metal to non-metal. So we have achieved the definition and example of ionic bonding. Now, properties of ionic bonding. Now, what are some properties of ionic bonding? They are hard and crystalline solids, usually. Okay, they also have high melting and boiling point. Ionic bonds have high melting and boiling point. And also they are soluble in polar solvent. Okay, explaining what polar solvent is another thing for another class. Okay. Now, conducting, they're also good conductors of heat and electricity. Okay, especially in their molten state. When we say molten, something that has been mixed up with in a solvent and now is no longer just solid, but it's now like a solution. Okay, or something that is semi-solid, not solid, not liquid, but in between, because there is a solute in a solvent. So that is for ionic bonding. Is there any question on that? Can we move on? Are there science learners even here listening to me? I was told this lesson is supposed to be for 23 students. So let us assume that 23 learners are all both science and art. So let us assume that the science students should be like 10 or 12, just assuming. But now I can see just one person because the other person is an art student and she's just here to observe according to her. So why are the rest of you not in the class? Someone has put in all the efforts in putting in this program for you, and the least you can do is to take advantage of it, because not every school or every learner would have this opportunity. At some point, you will need this knowledge. Even though you feel like, oh, I can get away with it, it's not WAEC, I will still pass somehow, whether it's by crook or whatever, I will still pass. But you get to a level where you need all this knowledge. Because you see that universities that some of you are aiming to go into, it will start from this basic knowledge. So when your mates are already ahead, when your mates are already at the next that at the level they are in, which is university level knowledge, that's supposed to be absorbing that by then, you will be thinking, oh, how do I start from the beginning? Because at the time where you were supposed to be listening to the beginning, you were not learning. So Like they would say, there is time for everything. Okay, now is the time to put in the effort so that when it's time for higher knowledge, you'll be able to pick up the pace. You'll be able to follow up what is expected for you to follow up with. Now the next one is covalent bond. Remember I said ionic bond is about transferring of electron. When one has more and they tend to transfer, give off to the other person, such that you and the person you're giving to become stable and happy. And so you are bonding, holding hands. Now, covalent bond has to do with sharing. You can see the keywords now. Ionic bond has to do with transfer, while covalent has to do with sharing. So these are the things you can take note of. These are the things you can write on the book. Covalent has to do with sharing of electrons. Please, if you have questions, as I am speaking, you can raise up your hand. Can jump, call me back, okay? And it involves non-metals. Sharing between non-metals, okay? So we don't deal with metals in covalent bonding. Now, covalent bond has to do with sharing of electrons, okay, to achieve a stable configuration. Stable configuration means having the octet, which is ending with a 8. Now, examples of covalent bond is CH4, methane. Now, how is methane covalently bonded? Methane is made of carbon. This is the formula for methane. And if you see, carbon is a metal, is a non-metal rather, and hydrogen also can act as a non-metal. Do you know that? Even though hydrogen is in the group 1 of the periodic table, it is one element that has a dual nature. So it also is represented as a non-metal. So that means the people that are involved in this bonding is 1 carbon and 4 hydrogens. Now the electronic configuration of carbon is 6 in the periodic table. So the electronic configuration will be 2, and what is left is 4. So that means it has 4 electrons in the outermost shell, not 8, so it is not stable. And it needs some other elements to bond with so that it will be stable. Now, hydrogen is 1 in the periodic table, and the electronic configuration is just 1. The same thing with this, the same thing with this, and the same thing with this. You know, we have 4 hydrogens. The electronic configuration is just 1. So now what happened in covalent bonding is that this carbon, okay, let's say carbon is in this circle. This is the valency of carbon. 1, 2, 3, 4. Remember, it's the outermost shell, this last one that partake in bonding, not the 2. We'll leave the 2 alone because it's this 4 that needs to achieve an octet. So it needs to be 8. So carbon is not going to donate its 4 or accept another 4. This is not transfer of electron. This is not ionic bonding. Covalent has to do with sharing, not donating and accepting, okay? So what will happen here is, since we have 4 hydrogens and each of those hydrogen has 1 electron, they are now going to share their 1 with carbon, such that one of the hydrogen will be here and it will share its one with carbon. Another hydrogen will be here and share its one with carbon. Another hydrogen will be here and share its one with carbon. And another hydrogen will be here sharing its one with carbon. So the 4 that carbon has plus the 4 shared by the 4 hydrogens, carbon is now going to be stable. It's now going to be having 8 electrons altogether. And also hydrogen will be stable. Hydrogen doesn't aim to achieve the octet structure, but the duplet, because hydrogen is a very small, has a very small atomic number. It's just 1. So it aims to be octets, to be stable, just like in helium. It doesn't aim, I'm sorry, it aims to be duplet, so it aims to be 2. Okay, so once the element has exceeded lithium, beryllium, they are now going to be aiming to be octet. So hydrogen is aiming to be 2, like helium. So that is why hydrogen is also stable here, because it's sharing 1 from the carbon. Okay. So look at the a diagram that can explain this. We see the red balls represent the electron for hydrogen, and the white balls represent that of carbon. So when the red balls and the white balls, they are sharing their electrons with each other. Now when you see it clearly, you see that um when you see it at this other end, you see that carbon is now having 1, 2, 3, 4, 5, 6, 7, 8 electrons all together, because of the 4 that has been shared by hydrogen. And if you see now, each hydrogen is having 2 electrons, which is achieving the duplet structure, duplet stability. Is anybody confused? Do you all understand? I see someone is raising their hand. Oh, okay. Obawumi was raising his or her hand. Okay, so that is for covalent bond. It has to do with what? Sharing of electron. The same thing happens in water. Okay. Okay, hello. I think I lost my network for sharing my screen. I was asking, what is the electronic configuration? What's the electronic configuration for oxygen? Yes. Someone should tell us so I would know the people that I've been following.
Two
Yes,
six.
Rina, are you saying something? Hello?
Two six.
Yeah. What are you saying? What's the electronic copy? You said?
Two six. I said two six.
26. Yes, very good. That's the electronic configuration for oxygen. So that to say oxygen is not stable. Or is it stable? What do you think? It,
It's not
it's
stable.
not stable, and that is
It needs
why,
to electron.
yes, it needs two electrons. And so since we're talking about bonding in water, oxygen, since we are talking about bonding in water, and water involves oxygen and two hydrogen, and each hydrogen has one electron to share. So they would share each of their one electrons with oxygen. So that oxygen will now turn from that 6 to becoming 8. And so it is stable and it has now bonded. Very good. I'm glad that one person at least is following us. Let me try to join in again and share my screen from my system. So just a recap. Okay, another thing that we can talk about in covalent bonding is their properties. Okay, covalent bonds. Covalent bond is almost like the reverse of ionic bond. Okay, they are not good conductors of heat and electricity like ionic bonds. Okay, and um they also have some other properties. Now, the next one that we will be looking at is dative bond. Dative bond can also be um, likened to covalent bond because it also involves sharing. But what is the difference? They are both different. So sometimes it is being called dative covalent bond, but it is different from the coordinate covalent, the first covalent bond that we talked about. Okay. Now, dative covalent bond also involves sharing of electron, but what makes it different is that it is only one element, one of the participating element or ion that is sharing. The electrons that they are sharing is coming from only one of the elements. The other one's own is to be receiving what is being shared. Okay, it's just like uh, it's just like having two friends where it's only one of them that is serious in class, and only that one will be the one teaching the other one. The other one has no knowledge to share or help the intelligent one with. And so the sharing of knowledge is only coming from one source and one source. Okay. But in covalent, sharing of knowledge is coming from both friends. Okay. So, and dative bonds usually have to do with ions, compounds that are ionic in nature, for example, ammonia and hydrogen. Okay, sharing my screen shortly. I'm just having network glitch.
Who knows the formula for ammonia? If I want to write ammonia now, what and what makes ammonia?
NH3.
Yes, very good. NH3 is what makes ammonia.
Makes ammonia.
Can you see my screen?
No, ma.
Okay, let me share it again.
Okay, let me share it again.
I believe it's visible now.
I believe it's visible now.
Yes.
All right, thank you.
All right, thank you.
Okay, we were at
Okay, we were at
dative bonds.
dative bonds.
I don't know why I'm
I don't
echoing.
know why I'm echoing.
Okay, dative
Okay,
bond.
dative bonds.
Okay, now
Okay,
we
we
can
can
see
see
from
from
here
here um an example which is
an example which is
formation of
now. Okay. Can you hear me now, Winner? You said my voice is echoing. Can you hear me now?
Yes, I can hear you.
Okay, it's no longer echoing.
Yes.
Okay. So now for ammonia, this first one here is what is ammonia. And this is hydrogen ion. Remember I said that when any element is having a plus charge, it means it has donated. Okay, so something like this means hydrogen has donated one electron. Then if we have something like this, means magnesium has donated 2 electrons. If we have something like this, it means aluminium has donated 3 electrons. And this donation will affect their atomic number. So if you know aluminium to be 13 in the periodic table, because we have aluminium 3 plus, it means it's no longer 13. That is the electron number of this aluminium is now 10 because it has donated 3. So plus means I have donated. So I have lost this amount of electrons. Okay. Now ammonia here, this hydrogen is being bonded to ammonia, and each hydrogen, each bond, each of this line, this is a bond now, okay, has 2 electrons that is forming it. So these 2 electron is what makes hydrogen to be stable. So let's assume this dot here and this dot here are the 2 electrons that makes hydrogen to be stable, and this bond 2 is also made of 2 electrons, and this bond 2 are also made of 2 electrons. These 2 electrons are called lone in chemistry. So it now means that how many electrons are now surrounding nitrogen? It is 1, 2. So let's say 1, 2, 3, 4, 5, 6. Okay, but nitrogen needs 8. So it's having 2 lone pairs here. Okay, now for this ammonia to be able to, these 2 lone pairs is making it 8, so that's 7, 8. This ammonium to be able to form ammonium ion, okay, it has to bond with this hydrogen. This ammonium here is already stable, even though it's having this lone pair. But you see, hydrogen has donated 1 electron. So what will happen here is this lone pair, for it, well, I can see it. Um, can you people see my screen now? Oh, Melody, you're a science student. Can you see my screen now, Melody? Okay, it was
Yes, ma'am.
Matilda that is not a science student.
Yes.
Okay. So now these pairs are now going to be shared with hydrogen. So it is the lone pairs from nitrogen that is bonding with hydrogen. Hydrogen is not sharing anything. Hydrogen is not contributing anything. It's only nitrogen that is contributing. And so this whole process here will now turn into this, where I said each line bond it represents 2 electrons. So nitrogen, for example, has 2, 4, 6, 8 electrons bonded to it. That means it is stable. Okay, and hydrogen has 2 bonds, each of them, which makes it also stable. So this is what ammonium. Ammonium is NH4. Ammonia is NH3. The same thing we can do for hydronium ion. Now this is the process here. The sharing, the contribution is coming from only one atom, from the nitrogen, and all hydrogen has to do is to participate, is to just share. It's not contributing anything. Okay. Then the next type of bond is metallic bonding. Metallic bonding always happens with metals. Okay, metals like sodium, magnesium, potassium, calcium. So when they bond with each other, for example, magnesium bonding with another magnesium gives us this. So this is example of metallic bonding. So some properties of metallic bonding: they are good conductors of electricity and heat, they are malleable, and they are ductile. So these are some properties. When we say malleable, what do we mean? Does anybody know? Malleable means materials that can be hammered into shapes. Okay, they can be hammered or casted into the different shapes that you want. Okay, and then we also have ductile. What does ductile mean? To be able to be drawn into thin wires. They are not the same thing. Malleability and ductility are not the same thing, but both of them are properties of metals. So what else are we supposed to learn today? How to draw. Okay, hydrogen bond. Hydrogen bond has to do with when hydrogen is directly bonded to negative elements like oxygen, fluorine, and nitrogen. Okay, so when we see structures where we have hydrogen bonded with fluorine, or anything like this, we know that this is hydrogen bond. But when we see something like this, okay, this one that I drew here that has to do with carbon and hydrogen, this is not hydrogen bonding. Okay, this is covalent bond. This is not hydrogen because even though hydrogen is there, the fact that hydrogen is there doesn't make it an hydrogen bonding. Okay, what makes it hydrogen bonding is when hydrogen is directly bonded, like in this case, directly bonded to a fluorine atom, oxygen atom, or nitrogen atom. Okay, so how to write formula for ionic compounds. Now there's what is called the crisscross method. Okay, let me just give some space. So we know every element what they need to be stable, right? So for example, oxygen, this is the configuration of oxygen 2,6. And so oxygen needs 2 more. And if it gets that 2 more, it's going to be accepting 2. So now this accepting 2, which is represented by -2, is called valency, okay, of oxygen. This is the valency of oxygen. Now, we can do the same for every other element. So for example, chlorine. Chlorine is 17, and so the configuration is 2, 8, 7. So chlorine needs 1 more to be stable. Okay, and so because it needs 1 more to be stable, if it gets that 1 more, it means it is accepting 1, and acceptance means negative sign. Okay, so this is the valency of chlorine. So we can do likewise for every other element. Now, this valency will help us to be able to write the formulas of ionic compound. Okay, so let us give ourselves some examples. Well, let us write the formula for magnesium chloride. We would also write the formula for so sodium oxide. Write the formula for calcium chloride. Okay, so all of these are ionic compounds. So we're going to write the formula for all of this. Let me give more example. Now, these more examples that I'm giving are questions I saw in your 2024 WAEC. So you were asked to write some reaction involving sodium oxide, um, phosphorus 3 oxide. No, this one is not part of it. Okay, I've already written magnesium oxide. Okay, but we can also do for this phosphorus 3 oxide and chlorine 7 oxide. Now, the crisscross method says when you're given an element like this, a compound like magnesium chloride, and you're being asked to write the formula, okay? We cannot just come and say this is magnesium and this is chlorine, and so this is the formula, because this is not the formula. A way to write this formula is to first identify what and what elements you can see there. When we see magnesium and chloride, we know that this is composed of magnesium and chlorine. So if we have that in mind, we'll put down our magnesium and we'll put down our chlorine. The next thing we'll ask ourselves is, what is the valency of magnesium and what is the valency of chlorine? The valency of magnesium is 12 in the periodic table. And so the configuration is 282. So who can tell me from this what the valency of magnesium is going to be? Based on what we did for oxygen and chlorine.
+2.
+2, very
Plus
good,
2.
because it will be donating that 2. So magnesium is +2. How about chlorine? Chlorine is -1. We already know that, right? So the crisscross method is saying that we will make this -1 of chlorine to be written here with magnesium, and this 2 of magnesium to be written with chlorine in their subscript. Subscript is the number that is written at the bottom, like this chlorine 2 now. This 2 is subscript. It's called subscript. Okay, so a proper way to write magnesium chloride is not just by writing magnesium and chlorine together, is by writing them and knowing their valency and exchanging each of them, exchanging their valencies. So this is going to be, if magnesium acquire the 1 from chlorine, so it's more like writing magnesium 1 and chlorine taking the 2 from magnesium, chlorine 2. You don't have to write the sign, the negative or positive sign. So this is properly written as magnesium chloride, MgCl2. this is the formula. So it's not something you just need to memorize. It's something that when you know the valency, you are able to write it on your own. Okay, so this will be magnesium chloride. Now, how about sodium oxide? Sodium is 281, and so it will donate 1. So that means the valency of sodium is 1. How about oxygen? Oxygen is 26, and so it will accept 2. So the valency of oxygen is 2. Okay, so sodium oxide will be like this. So we now have sodium acquiring the 2, oxygen acquiring the 1. So sodium oxide will be written Na2O. It is not just sodium and oxygen. No, this is how you properly write it. That's the formula. Now, the next one is calcium chloride. So someone should do that one for us. We have 3 options. A, calcium chloride. B, calcium chloride. And C, calcium chloride. So which of them is the proper way of writing calcium chloride? Yes. Between these 3 options, which of them is the correct formula for calcium chloride? When we know the
B.
valency of calcium, B, very good. Because the valency of calcium is 2 and that of chlorine is 1. And so
Right.
calcium is taking chlorine own and chlorine is taking
B.
calcium's own. Okay.
Sono B, sono chemistry now. Mm.
And the next one is phosphorus 3 oxide. Now when we see questions like this 3 here is telling us the number of oxygen. Okay, it's telling us that we have 3 oxygens. Okay, so a proper way to write this phosphorus 3 oxide, I will do this one. So this one now, phosphorus in the periodic table is 15, and so it's going to be 2, 8, 5, and then it needs 3 electrons. So the valency is 3. Let's put it that way. And oxygen is 2. We have already said that. Okay. Hello? Can you all hear me? Hello?
Yes, ma'am.
Okay, okay. So to write this one, oxygen is 2 and phosphorus is 3. So this oxide is already telling us we have 3 oxygen. So we are going to simply write it like this. And then our phosphorus is adopting the valency of oxygen as usual, 2. Okay. Then chlorine 7 oxide. The 7 there is telling
Ma'am,
us
I'm not seeing your
the
screen.
number.
Oh.
You can't see my screen.
I can see it now.
Okay. Now, chlorine 7 oxide, the 7 there is telling us the number of what? Oxygen. Okay, so our oxygen, we already know it's 7. We already know the subscript. And then for chlorine, we know if we're using that crisscross method, we know that the valency of oxygen is 2. So chlorine is going to adopt that too. So this is chlorine 7 oxide, Cl2O7. So these are some ways we can write ion. Then what if we have something like we have potassium tetraoxosulfate. Okay, tetraoxosulfate. These are things you just have to memorize. I mean, what um the formula for tetraoxosulfate. Like these are some formulas you just get used to. So SO4 is tetraoxosulfate. Okay. Then if you see something like nitrate is NO3. Nitrite is NO2 and so on. So for this one now, we already know that tetraoxosulfate is SO4. And the charge that this one is carrying is -2. So whenever you're being told tetraoxosulfate, the valency is 2. Then potassium is in group 1, and so the valency is going to be 1. So to write this tetraoxosulfate, we'll write it like this: K2SO4. Because the valency of this will come here, and this one's valency will come here. Do you all understand? I hope everyone is understanding. Okay, so I
Yes,
believe
ma'am.
you all do. All right. So do you people have any questions so far? I believe you are being, they usually take attendance with you, right? So I'm to just call your names, I believe so, and put it down, right?
Yes, ma'am.
All right. So we have U and U here. We just have Melody and Winner. Apparently, they have been the only active people in the class already. Okay, Melody Okosun and Winner Obawumi. So today we have learnt about naming some ionic compound. We have also learnt about types of bonds, and we have also learnt about what chemical bonding is. Okay, so if any of you have questions, you can ask now. You don't have any question?
I don't understand the
Ma, can you
last
just please do like
part.
a summary of what you have taught?
Okay. Okay, let me first explain the last part before I do a summary. Now, the last part, is it about the ionic bonding? How, rather, is it about The one where I said how to write the formula for some structures. Is that the last part you were talking about? Or how to name some structures? Winner.
Yes.
Hello? Is it this part you were talking about? This part you can see on the screen. Okay, but do
Yes.
you understand what valency is? When I explained valency, when I said
Yes.
oxygen, for example, okay, so you understand that oxygen's valency is 2 and chlorine's valency is 1. So this last part, this one last one I did. Is that the one you're confused about? The potassium tetraoxosulfate.
Yes.
Okay, so I was saying that tetraoxosulfate is SO4. Okay, that is the formula for it. It's something that you should just know. Okay, so when you are given a compound like potassium tetraoxosulfate and you are being asked to write the formula, that is writing it in symbol, what you should do is to identify what and what is here. Potassium is K, then tetraoxosulfate is SO4, and the charge of tetraoxosulfate is -2, and the charge of when I say charge, the valency, the overall charge or valency of tetraoxosulfate is -2, and that of potassium, if we go through it, potassium is 19 in the periodic table. So the configuration is 2A. Writes potassium tetraoxosulfate is by this one is going to be the subscript of the other ion, which is the SO4. And this 2, which is the valency of SO4, is going to be the subscript of potassium. So to properly write this, we'll write it as potassium 2, that is the 2 from the SO4. So they are just, that's why they call it crisscross. You make a cross and you the valency of one is written as the subscript of the other one. Valency of the other one written as subscript of the other one. Then SO4 will have the subscript 1 from potassium. You don't have to write 1. So the formula for potassium tetraoxosulfate is KSO4. K2SO4 rather. Do you understand, winner?
Yes.
Okay. Then Melody, in summary of all I've been saying since, we talked about bonding. And we said bonding is when we said bonding is the force of attraction that holds atoms or ions together to form a compound. The reason why ions would want to bond or elements would want to bond is so that they will achieve duplet or octet configuration. Duplet is for hydrogen, then octet are for those higher elements. Okay, so they want to be stable, like the group 8 element. They want to have 8 in their outermost shell. That is why elements bond. If everybody had 8 in their outermost shell, if they have complete configuration, they would not need to bond. That is why noble gases that have 8 in their outermost shell, this group 8, they are hardly bonding with any other element because they are already stable and complete. Okay, so that being said, we also talked about the types of bonds. Ionic bond, we say ionic bond have to do with transfer of electron. Okay, So it transfers of electron from metal to non-metal. So it involves metal to non-metal, and it involves transfer. That is, one is given to the other. Now, covalent bond involves sharing of electrons, and it involves two non-metals. Okay, there are no metals in covalent bonding. It involves non-metals. They share within, like, with themselves. So they share their electrons so that they will be able to be stable. Now we have dative covalent bond. Dative covalent bond is also involves sharing. But the difference is that the sharing is coming from only one of the non-metals. Okay, in the first simple covalent bonding, or the coordinates covalent bonding, this first one that involves sharing of electron, it involves sharing of electron between the two metals. The two metals are contributing in this sharing. But in dative, it's only one, the two non-metals rather. Did I say metal? The in dative covalent bond, it's only one non-metal that shares electron. Okay. Then the other one just accepts the sharing and participates in it. But they are sharing. Now, metallic bonding has to do with metals, a metal bonding with itself. Then hydrogen bonding has to do with hydrogen bonded directly to fluorine, to oxygen, or to nitrogen. If hydrogen is bonded directly to carbon, it doesn't mean it is hydrogen bonding. It must be directly bonded to fluorine, oxygen, or nitrogen. Okay, which are more negative elements. Now, we also talked about how to write the formula for ionic compounds using the crisscross method. Okay, so that's what we talked about today. Melody, did you get that? Did you get that, Melody?
Yes, ma. Yes, ma. Thank you.
All right. Okay, so I think that's the end of our class. If you have questions, you can still ask, or probably you send it along with your assignment or on the platform. Okay, you're raising up your hand, Melody.
I have a question. I cannot.
Okay, what's your question? Uh,
I cannot answer my assignment.
okay, you want to raise up your hand.
You say if I have a question, I can save it and log my assignment. So I'm asking, I cannot
Yes.
answer my assignment in dashboard.
Okay, you cannot put your assignment there. I don't understand what you're saying.
As in my answers.
Okay, you can't write your answers in the platform.
Yes, yes.
Why is that? Have you tried it with other subjects and it
Yes.
didn't work?
No.
Okay. Okay, then if you have questions, you can. How about you write the assignment and then you snap it and upload it in the platform? Can you do something like that?
Okay, I will try that.
Okay. But if it doesn't work, then in the next class, you also let me know. And if you still have questions, you can still ask in the next class. But for today, we have come to the end of today's class. Okay. I hope you both today. Melody and Winner.
Yes, ma'am.
Yes.
All right. So